Good day, everyone. Our topic for today is about bus and interconnections. I would like to thank my master student, Patrick Jude Bautista, for doing this PowerPoint presentation. So this is the block diagram of a Newman architecture, which is consists of a CPU, a memory, and an I/O, which are interconnected through a line consisting of an address, data, and control signals. The combination of the address, data, and control signals are called bus. In a single bus architecture, all bus signals are usually integrated together according to a certain standard, which can be easily connected to CPU, memory, video card, and network card, and other I/O devices. Shown here is the early motherboard. So earlier computers put CPU and memory together with some general bus interfaces on one circuit board, which is called a motherboard. So there are also other I/O cards such as video and network, which can be inserted later if they comply with the bus standard on the motherboard. So laptop computers and all-in-one computers are usually designed to integrate all circuits including CPU, memory, video, sound, and network cards into one circuit board. In these systems, the system bus is not visibly obvious, but it still exists as a traditional computers. So usually, a system bus consists of three subsystems: an address bus, a data bus, and a control bus. So the system bus referred to as all signals that connect to a processor. So for example, the CPU. So we have also here the memory, the secondary storage, the network interface, as well as the I/Os are connected with those different kinds of buses. So to define what are the functions of each bus, so we have the address bus. This is used for addressing a specific memory unit or a specific I/O device. So the width or the number of lines determines the CPU's addressing ability. So for example, we have an 8-bit processor. So the addressing space is 256, which is 2 raised to 8 or n bits. So for a 32-bit processor, so the addressing space is 4 gig. With regards to the data bus, this is used for accessing data with the main memory. The wider it is, or the more data lines it is, the more data the processor will be able to access at one time. For an 8-bit data bus, so data can be read or write 8 bits at one clock cycle. So if the data contains 30 bits, then it requires 4 reading times to get the data. While for a 32-bit data bus, it only requires 1 read instructions to get all the 30 bits data. So in terms of bus, we have different kinds of connections. So we have the parallel bus and the serial bus. Buses on the motherboard are mostly parallel buses. A word of data can be read from memory at one time with 1 instructions. The industry standard bus or the ISA bus and the peripheral component interconnect or the PCI, as well as the mini PCI and STD bus are all parallel buses. PCI Express. PCI Express is a high-speed serial bus that has 1 to 32 bits bus width. So it is commonly used for these array controllers, gigabit Ethernet, and Wi-Fi to supersede the accelerator graphics POS or the AGP and the PCI buses. Another thing is the universal serial bus, or which is commonly known as the USB. So this is the most common serial bus we are using right now. It can connect with most computer peripherals such as keyboard, mouse, printers, and external hard drives. So a standard USB connector has 4 pins, 2 reserved for data and 2 for the power, which is the VCC and the ground. So it shows the cable wiring for a USB 1.0 as well as 2.0. To reduce the interference, so the 2 data lines are paired and twisted. So USB 2.0 is able to transmit at a speed up to 400 Mbps. It is generally considered sufficient for a variety of devices. However, with today's ever-increasing demands on high-definition video content and terabyte storage devices, this speed is not really fast enough. So that is why it came out the USB 3.0 or the super speed USB, which has a transfer rate of up to 5 gigabits per second. So it has a backward compatibility with USB 2.0. So in addition, it provides better power management features. So parallel buses and parallel communication. So with regards to telecommunication and computer science, parallel communication is a method of sending several data signals simultaneously over parallel channels. The basic difference between a parallel and a serial communication channel is the number of distinct wires or strands at the physical layer used for simultaneous transmission from a device. So parallel communication implies more than one such wire strand in addition to a ground connection. An 8-bit parallel channel transmits 8 bits simultaneously. A serial channel would transmit those bits one at a time. If both operated at the same clock speed, the parallel channel would be 8 times faster. A parallel channel will generally have additional control signals such as the clock to indicate that the data is valid and possibly other signals for handshaking and directional control of data transmissions. Serial bus and serial communications. So after discussing the parallel, we'll now go with the serial communication. So obviously, serial communication is the process of sending data one bit at a time, sequentially, over a communication channel or a computer bus, where several bits are sent as a whole on a link with several parallel channels. Serial communication is used for a long-haul communication and most computer networks where the cost of cable and synchronization difficulties make parallel communication impractical. Serial computer buses are becoming more common even at shorter distances, as improved signal integrity and transmission speed in newer serial technologies have begun to outweigh the parallel bus advantage of simplicity and to outstrip its disadvantages. So the migration from PCI to PCI Express is one good example. So an example of such low-cost serial bus is the Serial Peripheral Interface or the SPI. So integrated circuits are more expensive when they have more pins. So to reduce this, the number of pins in a package, so many ICs use a serial bus to transfer data when speed is not important. In many cases, serial is a better option because it is cheaper to implement. So many ICs have serial interfaces as opposed to parallel ones, so that they have fewer pins and are therefore less expensive. So one example of this is the RS-232, the Morse Code, the Ethernet, the musical instrument digital interface, USB, the SAS, the serial ATA, PCI Express, Sonnet, and so on. So Morse code. Morse code is a method of transmitting textual information as a series of on and off tones, lights, or clicks that can be directly understood by a skilled listener or observer without special equipment. The International Morse Code encodes the ISO basic Latin alphabet, some extra Latin letters, and Arabic numerals, and a small set of punctuations and procedural signals as standardized sequences of short and long signals called the dots and dashes, or the dits and dash. Because many non-English natural languages use more than 226 Roman letters, the extension of Morse code alphabet exists for those languages. So also, Morse code speed is measured in terms of words per minute or characters per minute. So one important feature of Morse code is the coding efficiency. The length of each character in Morse is approximately inversely proportional to its frequency of occurrence in English. So the different code was there are also related code which was originally created by Samuel F. B. Morse for the electric telegraph by Alfred Vail in the 1840s. So this code was the forerunner in which the modern international Morse code is based. And then Morse code is most popular among amateur radio operators, although it is no longer required for licensing most countries, including US. So because it can read by humans without a decoding device, Morse is sometimes a useful alternative to synthesized speech for sending automated digital data to skilled listeners on voice channel. So for emergency signals, Morse code can be sent by a way of improvised sources that can be easily keyed on and off, so making it one of the simplest and most versatile methods of communication. The most common distress signal is the SOS. So we have three dots, three dashes, and three dots, which is internationally recognized by the treaty. Okay, another type of connector is the RS-232. It is one standard feature of a PC for connections to modems, printers, mice, data storage, uninterruptible power supplies, and other peripheral devices. So however, the limitation transmission speed, this is limited to the transmission speed, its relatively large voltage swing, and the large standard connectors motivated development of the USB, which has displaced RS-232 from most of its peripheral interface roles. Many modern PCs have no RS-232 ports right now, and most use external converters to connect to other peripherals. So some RS-232 devices are still found, especially in industrial machines or scientific instruments. So both standards have software support in popular operating system. USB is designed to make it easy for device drivers to communicate with hardware. However, there is no direct analog to the terminal programs used to let users communicate directly with serial ports. So USB is more complex than the RS-232 standard because it includes a protocol for transferring data to the devices. This requires more software support for the protocol to be used. For RS-232, only standardize the voltage of signals and the functions of the physical interface pins. So for RS-232, you can directly program or do interface using your computer, unlike for the USB, which you need another circuit or software to interface the I/O ports. Serial ports of PCs are also sometimes used to directly control various hardware devices, so such as the relays or lamps, since the control lines of the interface can be easily manipulated by software. This is not feasible with USB, so which requires some form of receiver to decode the serial data. Unlike for RS-232, you can directly interface your relays or lamps as well as your switches or LEDs to the port. So next one is the Ethernet. Ethernet is a family of computer networking technologies for local area networks, or the LAN, which was commercially introduced in 1980. So standardized in IEEE 802.3. Ethernet has largely replaced competing wired LAN technologies. So Ethernet evolves to include higher bandwidth, improved media access control methods, and different physical media. So the coaxial cable was replaced with point-to-point links connected by Ethernet repeaters or switches to reduce installation cost, increase reliability, and improve management and troubleshooting. Many variants of Ethernet remain in common use. So the standards define several wiring and signal variants. So the original 10-base-5 Ethernet used coax cable as a medium shared. So since its commercial release, Ethernet has retained a good degree of compatibility. Its features such as the 48-bit MAC address and Ethernet frame format have influenced other networking protocols. The next one is the MIDI, or the Musical Instrument Digital Interface. So this is an electronic musical instrument industry specification that enables a wide variety of digital musical instruments, computers, and other related devices to connect and communicate seamlessly with one another. The primary function of MIDI includes communicating event messages about musical notation, pitch, velocity, control signals for parameters, bit, clock signals between multiple devices. These complete a signal chain and produce audible sound from a sound source. For users, MIDI enables a single player to sound as they are playing two or more instruments simultaneously. As an electronic protocol, it is notable for its widespread adoption throughout the music industry. So the standard applications of MIDI or electronic keyboards. So these synthesizers and samplers, which features a built-in keyboard, MIDI keyboard, which is also referred to as the MIDI controller or the hardware music workstations. For a personal computer, so it is equipped with an internal MIDI capable sound card. For the MIDI interface, so you used to connect MIDI devices to devices without built-in MIDI compatibility capability. Common usage scenario is enabling MIDI support for a computer via an external sound card which connects via a USB or FireWire. So other applications include interconnectivity with analog audio outputs, microphone inputs, optical audio cables. Another standard application of MIDI is the audio control surfaces. So often resembling a mixing console in appearance, enable a level of hands-on control for changing parameters such as sound levels and effects applied to individual tracks of a multi-track recording or live performance output. You can also have digital effect units. So this applies audio effects such as the reverb, delay, and chorus to simulate the sound of the music being played in a large hall or in a canyon or with multiple voices all playing at once respectively. Another application is the digital percussion devices. So this triggers percussive or other relatively short sounds, usually via specifying a pattern or order in which the sounds should be played on a drum machine or a rhythm machine. So other musical instruments, so non-traditionals and DIY devices custom built to accept MIDI input or devices adopted with additional hardware to provide MIDI compatibility signals. The MIDI guitar and MIDI violin are two such instruments. Okay, next is the synchronous and asynchronous bus. So synchronous buses use system clock to provide time information for all signals on the buses. A signal is considered invalid unless it is synchronized by the falling edge or the rising edge of the clock. On the other hand, signals should be in a stable state before the clock edge to support competition that may cause the circuit or system to be unstable state. When CPU wants to read data from memory, the address signals is first enabled and then the read command is issued. So the data will not read until the next clock edge is reached, so that the time of the read action has taken place. So all data are already stored in the memory data register and in stable conditions. So DMA uses synchronous method to transfer data once the initial negotiation process is succeeded. A block of data will be transferred between the device and memory synchronized by a common clock. So for the single bus and the multiple buses. So a bus is usually referred to as an address, data, and control signals that connect to a processor. An actual computer may have more buses than just only one single bus. So for example, a PCI bus that is used to connect SCSI LAN and an onboard memory, as well as the keyboard, mouse, and other ISA cards. So they may be an IDE that connects old IDE hard drives and CD-ROMs. So the figure shows the diagram of a computer with above-mentioned buses. It shows that there are many buses in a computer system. So if we look into it, we can start it that is essentially a single bus system. In addition to the PCI bus, the AGP is merely a graphic accelerator, so it goes through a bridge that bridges AGP and PCI together. So similarly, ISI and IDE also go through a bridge that exchange similar signals between ISI and IDE with PCI, so it is intended to a single bus with some variations. So for computers with multiple processors located in a central location or distributed locations are generally considered as a parallel processing system. So here we have multiple processors means multiple processing units. So it is different than multi-core computers. Okay, so security considerations for computer buses. Fewer people have studied the vulnerabilities of computer bus to attackers. A computer system can be taken over from devices that are attached to the computers. So the data stored on the computer can also be exposed to the programs or virtual machines that were booted from a USB memory attached to a computer USB port. So a dual bus interface design. So this is a circuit that connects one device to two buses and enables the device to be accessed simultaneously from these two buses. So being able to access from both buses at the same time is the key for a dual bus interface. So here is an example which is an external DVD which may have two or more buses, the USB and the 1394 that can be connected. So this does not require necessarily mean it is a dual bus enabled. We can choose to use either USB or 1394 to connect to a computer system. Since normally we cannot connect both buses to a computer system, so therefore it is not a dual bus device. A dual channel architecture. So for a dual channel enabled memory controllers in a PC system architecture, it utilizes a 264-bit data channels. Dual channel should not be confused with double data rate or the DDR, in which data exchange happens twice per DRAM clock. The two technologies are independent of each other and many motherboards use both by using the DDR memory in a dual channel configuration. For a dual channel architecture, it requires a dual channel capable motherboard and a two or more DDR, DDR2 or the SDRAM memory module. So if the motherboard has two pairs of differently colored DIMM sockets, so then one can place a matched pair of memory modules in bank 0, but a different capacity pair of modules in bank 1, as long as they are of the same speed. So using this scheme, a pair of 1 gigabyte memory module in bank 0 and a pair of matched 512 MB modules in bank 1 would be acceptable for a dual channel operations. So modules rated at different speeds can be run in dual channel mode, although the motherboard will then run all memory modules at the speed of the lowest module. Some motherboards, however, have compatibility issues with certain brands or models of memory when attempting to use them in a dual channel mode. So for this reason, it is generally advised to use identical pairs of memory modules, which is why most memory manufacturers now sell kits of matched pairs DIMMs. Several motherboards manufacturers only support configuration where a matched pair of modules is used. So a matching pair needs to match in. So for example, for a capacity, we have 1024 MB. So certain Intel chipsets support different capacity chips in what they call flex mode. The capacity that can be matched is run in dual channel, while the remainder runs in single channel. Next consideration is the speed. So for example, for PC 5300, if the speed is not the same, the lower speed of the two modules will be used. So likewise, the higher latency of the two modules will also be used. Next is the number of chips and sides. So example, we have two sides with 4 chips on each side. And then the last one is the matching size of rows and columns. So for a dual channel configuration, it alleviates the problem by doubling the amount of available memory bandwidth. So instead of a single memory channel, a second parallel channel is added. With two channels working simultaneously, the bottleneck will be reduced. So rather than wait for a memory technology to improve, dual channel architecture simply takes the existing RAM technology and improves the method in which it is handled. While the actual implementation differs between Intel and AMD motherboards, are the basics theory standards. So there have been varying reports as to the performance increase of dual channel configurations, with some tests citing significant performance gains, while others suggest almost there is no gain. So the difference can be far more significant in applications that manipulate large amounts of data in the memory. So a comparison of Tech Connect magazine demonstrated considerable gains for a dual channel in tasks using the block size is greater than 4 MB and during stream processing by the CPU. The triple channel architecture. So when operating in a triple channel mode, the memory latency is reduced to interleaving, meaning that each module is accessed sequentially for smaller bits of data rather than completely filling up one module before accessing the next one. Data is spread among the modules in an alternating pattern, potentially tripling available memory bandwidth for the same amount of data as opposed to storing it on one module. So the DDR3 triple channel architecture is used in the Intel Core i7-900 series, also in the LGA 1366 platform. AMD socket AM3 processors do not use the DDR triple channel architecture, but instead it uses the dual channel DDR3 memory. So the same applies to the Intel Core i3, Core i5, and Core i7-800 series, which is used on the LGA 1156 platforms. According to the Intel, a Core i7 with DDR operating at 1066 MHz will offer peak data transfer rates or 25.6 gigabits per second when operating in triple channel interleave mode. So this Intel claims leads to for faster system performance as well as higher performance. The architecture can only be used when all four or multiple of four memory modules are identical in capacity and speed and are placed in a quad channel slots. When two memory modules are installed, the architecture will operate in dual channel mode. So when three memory modules are installed, the architecture will operate in a triple channel mode. So DDR3 quadruple channel architecture is used in the AMD G34 platform and the Intel LGA 2011 platform. AMD processors which are used on the C32 platform instead use dual channel DDR3 memory. Intel processors which are used on the LGA 1155 platform instead use a dual channel DDR3 memory. So a dual bus memory interface. So the diagram shows a dual bus interface. So here control signals EN is used to enable or disable the communication between the bus and the storage S. So you can choose what kind of bus you would like to enable. For a dual bus memory module, so one example is the Motorola MPC8260. This is a chip that contains a 64-bit PowerPC microprocessor and a versatile communication processor module or the CPM. So the MPC8260 is used in a wide array of applications, especially those in the communications and networking markets. So examples include remote access servers, regional office routers, cellular base stations, and SONET transmission controllers. So a lattice ISP GDX2TM generic digital crosspoint switch is used as a multi-port interface. So this is a device that can interface the MPC8260 with an external master and a number of slaves including SDRAM and flash. The control logic for the SDRAM and flash is built in a CPLD which is used to interface with the MPC8260 to the ISP-GDX2 device and to control the read-write to the memory. So this function can be implemented in lattice CPLDs. Okay, So to summarize, so in this module, so we study different kinds of computer buses and how different components are interconnected. A system bus is composed of an address bus, a data bus, and a control bus. The address bus determines the addressing space. So in other words, it specifies how many memory can be attached onto a computer system. So for a data bus, so how much data can be read or write. And the wider data bus will reduce the read-write times, so therefore increase the system bus. Thank you very much.